Good morning. Assalamualaikum. Can you hear me?
Yes, Miss.
Yes, Miss.
Okay, good. Thank you for responding. Now, so we will continue to our lecture. Just stop me if you don't understand or raise your hand if you have question to ask. Yeah? Can you see the slide?
Can.
Okay, good. We are using the slide integration of unequal segment. Is it? Are you using the correct slide or not? Integration.
Yes,
of...
Miss.
Okay, good. Now, okay, so we proceed to our lecture. Hey, wait. Sorry. I think I shared the wrong slide. Wait, one is unclean one. Let me share again. Okay, now this is what we had done earlier in our class yesterday. We had done Simpson 1/3 and Simpson 3/8. Okay, yesterday we had practice on Simpson 3/8. Now I would like to continue for B, which is a combination of Simpson's 1/3 and Simpson 3/8. Okay, because it asks you to use it in conjunction with Simpson's 1/3 rule to integrate the same function for 5 segments. Okay, 5 segments. So n equals to 5, meaning that you need to use the Simpson's 1/3 plus 3/8 rules for whole 5 segments. Okay, so we combine. Later on, the total integration will be summation of integration of 1/3 and integration of 3/8. Okay, so this is the data that you need. Okay, 5 segments. N equals to 5. Okay, we need to know what are the data that you need. So the X okay, involve 6 points. So X naught until X5. Okay, so then find out what is your value of X's. Remember, X naught is A, X5 is B. Okay, the A and B remain, which is 0 to, what is it? 0 to 0.8. This one, Now, so A, X naught is 0. Last point should be 0.8. Now we need to find out each point what is the value. In order to do that, you need to find the H. Okay, first step just now, you should find what is the H. Okay, B minus A over N. So 0.8 minus 0 over 5. You will get 0.16 as stated over here. Okay, so from there to find your X1, X0 plus X1. Okay, X0 plus X1, so you get here 0.16. So this is your data point. X4 is 0.48. In this example, this is the value of the X. Okay, X0, X5. because it is fx. Okay. Then after you determine your axis point, so you should find out what is your fx. As given over here, the fx value. How to get this? You input in the earlier equation. This one. Using the same equation. Okay, so input the axis in that equation, you will get this value. Okay, so I just copy it over here. Okay, so this is your infos, data points, and also the f-axis. Now, it asked you earlier to use 3/8 rules in conjunction with 1/3. Okay, so 5 segments. Okay, let's say, for example, let's say this is the curve, for example, 5 segments from A to B. Okay, 5 segments. We have identified the H. Okay, this is your X0, X1, X5. Okay, now, how to know which part to use 1/3, which part to use 3/8? Okay, what is the minimum point for 1/3 rule? What is the minimum point of 1/3 rule?
2 segment.
Sorry?
2 segment.
2 segments mean 3 points, right? 1/3, you have 2 segments, 3 points. Okay, 3/8. 3/8, how many segments?
3 segment.
3 segments, correct. Minimally 4 points. Okay, now 3 points. So 1/3. You can choose to use 1, 2, 3, 2 segments. So this part, you apply 1/3 rule. Then the other part, you use 3/8 rules, 3 segments. Okay, so the 3 segments, the 3/8 rules, so these are the points. Minimally 4 points. Okay, so this is, you can use as 3/8. The red one is 1/3. Or you can start with 3/8, last with 1/3. As long as you use both. Okay, in this example, it used the integral for first 2 segments is obtained using 1/3. So it used 1/3 for the first 2 segments. This part is 1/3. Okay, so it applies the 1/3 rules for the integration equation. Okay, 1/3 rules, I h over 3. Single application because we only use once for minimum 2 segments. So single application of 1/3 fx0 plus 4. Okay, for the intermediate part. There's no only involve two segments, so 3 points. So this one only involve fx1. Okay, then plus the fn, which is the last point, fx2. Okay, so that's how it get to this answer. Any question? Okay, the last three segments, it used 3-8 rule. So it used the equation of 3-8 integration. Remember, this 3-8 rule, it start from x2 point. Okay, here, x1 to, it needs 3 points for 1/3. Okay, then 4 points for 3-8. 4 points. So it should start from x2. If you start from x3, okay, let's say you are confused, you trade from x3, not enough point, and then you left out this segment. You will left out this segment. So that's why we start from x2. x2 is the end point of 1/3, and x2 is the starting point for 3-8. Okay, so this is for 1/3, 3-8, using the equation of 3-8. Okay, so you get this value of integration. Then after you obtain both integration values for both rules, then you sum up all together. So I total, here is total, from I 1/3 to plus I 3/8. So you see, you will get the total integration, which is approaching the actual value, the true value. This is your approximate value. This is your true value that you calculated earlier. Exceed a bit, but still within acceptable limit. Error of 0.28%. Any question? Okay, take your time to understand and digest first. I give you 2 minutes before we proceed to the next part. For the attendance, you cannot scan yet because it is not our class hour yet. So attendance I will download from the attendance list in here, the participant list. Yes, Hala, any question?
Miss, I think there is something wrong in the value of fx.
fx. Which fx?
Fx2 and I think fx2 is 1743393.
Oh, okay. From my table over here. Yes, yes.
Yes.
Sorry. Okay, you follow here. This is the correct value.
Okay.
Sorry, I copied wrongly.
And you flip x3 and x4.
Yes, correct. I copied wrongly. Thank you, Hala.
Thank you.
Okay, I proceed to the next part. Okay, this is the summary of the trapezoid Simpson's, both Simpson's rule. Okay, now you see the how it applies. Trapezoidal rules every 2 points, because we need to calculate each of the trapezoid. Okay, let's say this is the function. Now you need to calculate each of these trapezoid. So every 2 points. Higher order, lesser error. So let's say sorry. Let's say your segment is only one segment. Okay, A. Let's say your A, this is your B. So if only one segment, it only involves one trapezoid. So the whole thing here, one segment. Okay, that one is if n equals to 1. So if you separate more segments, let's say for this curve, the more curve here, wait, give me a few minutes. Okay, let's say you have many segments as stated over here. Okay, then I delete this one. Let's say you have many segments. So you must calculate for each of the segments. That's why when you have many segments, then you need to use for the multiple application equation. So this works for multiple. Mean multiple segments. Okay, if single segments, what is the equation? Still remember? Single trapezoid. What is it? Can someone share me the equation? What is the single application for trapezoid?
fx naught plus fx1 times h times ab times b minus a, then over 2.
Yes, correct. Over 2. So this is for single application. The distance A, B to A, then fx naught plus fx1 over 2. Or fa plus fb over 2. Okay, that one is only for single. Divide by 2 is always trapezoid. Okay. Just now Yongxing just now share the equation. Thank you. Okay, so we proceed to this Simpson's wanted. Here it mentioned every 3 points. Okay, as we have learned earlier, Simpson's rule minimum is n equals to 2. Okay, n equals to 2 minimally. So minimum 3 points. If you have 4, 6, 8, usually it works with even orders. Okay, even orders. Okay, how to know? Okay, how to know if these orders works with 1/3 or 3/8? Okay. Now let's say here this is 2 segments for this curve. So 1/3, 2 segments, 1, 2, 3 points. Okay, let's say you have 4 points. N equals to 4, so you have 5 points. So additional one, x0, x1, x2, x3, x4. Okay, 4 segments. Sorry, 4 segments, 5 points. Okay. Now, how to know this one works with 1/3 or 3/8? Remember 1/3, you must involve 3 points. Okay, you must involve 3 points. So this part is the first 1/3. So another part is the second 1/3. Okay, so the total integration later on is equivalent to this integration plus this side integration. Okay, that one if you want to do single, but if you input directly to this, just use one equation. Okay, so this one means that the summation of all this. Okay, let's say n equals to 5. Let's say you have n equals to 5. I delete this part. N equals to 5 means how many points that you have? n equals to 5.
6.
Right, 6 points. Okay, so 6 point, 5 segments, 6 point. Okay, let's say like this. Okay, I just want to show how it works. Ignore the unequal. Now, 6 points. So x naught until x5. So let's say you want to use 1/3. We know that 1/3 must involve 3 points. So this one can use 1/3. This 3 point can use 1/3. But this one not enough to use the 1/3. So not enough point to use 1/3. Okay, so that's why N5 doesn't applicable with 1/3. Okay, so that's why you see there's none of 5 segments over here. That's how to confirm whether each of the n order works with which rule. Okay, even with 3/8, it doesn't work as well. Okay, let's say 3/8, we need minimally 4 points. Okay, minimally we need 4 points. So 1, 2, 3, 4. This one works with 3/8. Left only 1, 1, 2, 3. So this one doesn't work with 3/8. Cannot use 3/8. So that's why N5 also doesn't appear in the 3/8. Okay, in this case, you need to use combination. Either 1/3 plus 3/8 or 3/8 plus trapezoidal, multiple trapezoidal. Clear? Any question?
No question.
Okay, good. Now I proceed to unequal segments. Unequal segments, if we cannot use all for the same rules. Okay, for example, we have here. Okay, we have this function with these given segments. Here we have how many segments? 1, 2, 3, 4, 5, 6, 7 segments. So n equals to 7. So you will have x naught up to x7. Okay, you can use a combination of the integration. Okay, you can choose to use trapezoid rule for the first segment and the last segment. Then the next two segment you use 1/3 rule. Then these segments you use 3/8 rules. Okay, it's up to your judgment. If you say you want to use all trapezoidal, works as well because trapezoid works with every 2 points. Trapezoid every 2 points. Okay, so it works as well. If you say you want to use just trapezoid, multiple application of trapezoid, works as well. Or you can use a combination like this. So if you use combination like this, your final integration, total integration would be integration of the first trapezoid plus integration of 1/3 plus integration of 3/8, then integration of second trapezoid. Okay. Let's say you don't want to use this, you want to try just 1/3 and 3/8. Okay, let's see if it works. Okay, let's see if it works. 1/3 and 3/8. You want to use combination 1/3 and 3/8 only. So 1/3, we know that it must be 3 points. 3/8 must be 4 points. Okay, must involve 4 points. Now let's say focus on the green ink. Let's say this 1, 2, 3. Okay, this one 1/3. Another 1/3. Then 1, 2, 3, 4. The last part you want to use 3/8. It works as well. As long as you can integrate the whole segments. Okay, so from this function, this curve, there are few options for you to calculate the integration. So for the green ink, your total of integration would be integration of the 2 1/3 plus integration of the 3/8. Okay. Understand how to choose which rule to be applied for the function, for the required segments. Okay, so if let's say you choose you say I want to use only 3/8 rules. Okay, let's see if it works. Wait. Okay, let's see if it works. I copy this one first. Okay, I copy here lah. Okay, we have one more segment over here just now. Okay, you say you want to use 3/8 rules, all 3/8 rules. Just now we have n equals to 7. Okay, you want to use 3/8 rules only for all, multiple application. 3/8 rules, we need 4 points. Okay, so let's see if it works. This one, the first 3/8. Okay, 1, 2, 3, 4. Now this part you can use 3/8. But if you just decide to use 3/8, you will leave out one segment over here, not calculated, not integrated, so it won't work. So we cannot use only 3/8 rules. In this case, you can also add it with trapezoid. So the last segment, you can use trapezoid. Okay, so for this, 3/8 rule, only it doesn't work. You must add with trapezoid. So total of integration over here would be the both 3/8 integration plus the integration of the trapezoid. This works too. As long as all area under the curve is being integrated. Doesn't matter which rule that you want to apply. Okay, clear? Now this one, I wanted to show you the difference. If you have this kind of curve, let's say at your A and B between negative pi to pi. This is your A, B. Okay, if you choose to use 1/3, 1/3 should have 3 points. 1/3, 2 segments, so your H, you must find what is your H. Then find the next point. Let's say 1/3, you have 2 segments, 3 points. Okay, so identify what is your H. From A to B. Okay, so let's say this is your this is your x1. So x0, x2. So the integration under the curve, it involves between these 2 points. Okay, if you do straight line from x0 to x1, you will notice error here and perhaps some error over here, this side as well. Okay, but let's say you choose to use from the same segment, the same A and B. Now let's say trapezoid. Trapezoid single. I want to show the difference. So single only A to B. A, B. Okay, so the area under the curve that you will cover only this part. Okay, notice how big the error is. This is the error. Okay, so that's the difference in choosing which rules and how many segments that you need to use. The higher the segments, the lesser the error. Okay, clear on that, huh? Now this one you can try on your own. This one it use multiple trapezoid. Okay, this equation is multiple trapezoid. Then it also use this. Okay, what is this equation?
Pardon, Miss?
What is this equation? Which rule?
1/3.
1/3 rule, yes, correct. wanted, Simpson wanted. See here, it refers h over 3. Okay, now the truncation error I will pass. Okay, we focus on the true error and approximate error only. This one also I will pass. I want to focus on the unequal segment. Okay, this one you can try on your own. Now I want to do this one first. Last year test for B. Okay, given integration of this function, it asks you to apply both Simpson one-third rule and trapezoid rule to solve the integral, including the true error. Okay, here, what the question means is, apply both Simpson's one-third and trapezoid. Means that total segment is 5. For apply Simpson's one-third for n equals to 2 and trapezoid rule for n equals to 3. Okay, this question means you have a total of 5 segments. Okay, n equals n 2 segment. For 2 segment, use 1/3. Okay, the rest of the 3 segment use trapezoid. That what is the question means. Okay, so the green segment is 3 segments. So this part you should use trapezoid. So later on, your integration, total of integration of 1/3 plus integration of trapezoid. Okay, try first. N equals to 5. So first step is to find what is your h. Then generate the table of the axis and f-axis. Okay. Lastly, you input into the required equation. Okay, you try first. Later we discuss. I think 10 minutes should be enough. Okay, after 10 minutes, we shall discuss the answer.
you close your mic.
Yes. Okay. Now let's discuss. Bufan, what you get for I wanted, integration of wanted? Bufan, what do you get for integration of wanted?
I get 84.8767.
Come again?
84.8767.
This one. Correct? Do I copy it correctly? Okay, how about the rest? Do you get the same or you get different answers? Hala, what do you get? Hamizan, okay. Hamizan, same,
Different.
different. What you get?
I got 50.481.
481.
Yeah,
50.481. Okay, this is only for the I wanted. I want to know not the final answer yet. Okay, thanks,
okay,
Hamizan.
for
Huh?
if wanted,
Ah,
my answer is 3.6611.
wanted 3 points,
6611.
3 point, 3 only.
Yeah.
Okay, okay.
I missed my answer. My answer is 5.4961.
1961. For wanted.
Yes.
Yes.
If for
Yes.
wanted, I did the same
Five.
as me. 5.4961.
Okay, okay. Thank you. How about the rest? You get 5.4 or 3.6?
5.4.
5.4. Okay, so most answers get 5.4. Hamizan, perhaps you need to check back your answer. Okay, this is for I wanted. Okay, for the integration wanted, here refers to the first two segments. If you use the last two segments, then it will be different answers. Okay, we just set for the first two segments over here. Okay, now how about the integration of the trapezoid?
One 119.07.
Sorry,
119.07.
107. The rest get the same?
I get the same.
Okay, good. Okay, so total of the integration is the summation of both area. Okay, so from here, if you sum up, you will get the final answer. Okay, anyone get different answer? Okay, so all clear how to get the answer. Now this question also you can choose, because here the question it doesn't mention first two segment you need to use this, last three segment you need to use this. It doesn't specifically mention, so you can choose either the first two segment as wanted or the last two segment as wanted, as long as you apply both rules. Okay. Now this I share with you the mark distribution. My answer slightly different, because this one I think I use first two is trapezoid. First three is trapezoid. First three is trapezoid. The last two is Simpson. Okay, we go. Now this is how the mark being distributed for this question. Okay, to know you need to find the true value. Okay, true value. Subs in the calculator. Sub the equation to the calculator using this A and B. Okay, so the values of the x-axis and the f-axis get marked, and then input into the correct equation you get marked. Final answer. Okay, then this question it also asks you to include the true error. So that's why just now in the first place you should find what is your true value. Okay, so that's why the true value here you get marks. Okay, then input the final answer of true value, then the total area for trapezoid, and then this one application of the Simpsons and trapezoid.
Miss,
Yes.
why my true value get 121.49?
5. Yes.
1 to 1
Yes.
Yes.
Then here it should be 1 to 1 Not sure how I get this. 1 to 1 point
49.
49.
Yes.
0.49, okay. Okay, so from what you get of the true value, compare with your approximate value that you calculate. Okay, so it's approaching the true value. Okay, perhaps my answer something wrong. I think I key in wrongly for the equation. That's why I get this. So as long as you get your total value of integration similar to your true value, then it should be you are on the right track already. Okay, from there you should calculate the true error. Your approximate value, this is your approximate value. Okay, true value minus approximate value. Then multiply 100. Okay. Okay, so we are done with chapter 5A. The rest of the question, you can try on your own or if we have enough time, I will conduct a session to do the exercises. Okay, so any question before we stop? Okay, no question? Just to recap, this chapter 5a, we have learned about integration under the curve using trapezoid, Simpson's 1/3 and also Simpson's 3/8, plus the application of all for unequal segment. Okay, so integration, it always involves trapezoid, Simpson 1/3, Simpson 3/8 for now. Okay, later on when it involves Romberg, additional of this. Okay, any question before we stop?
No.
Okay, so I hope you are
Thank
clear.
you.
Okay, I hope you are clear and understand what we learned today. See you next week.
Okay,
Okay,
thank you,
that's
Miss.
welcome. Bye bye.
Thank you, Miss.
Thank
Bye.
you.
Miss.
Welcome.
Thank you, Miss.
Welcome.